Hello and welcome back to Tovi. This particular tutorial and session will focus on the QC screening tool. Now up on this top menu here, there's a toolbox option on the menu. And we open up and see a variety of tools we could use. We're going to go into the quality screening tool. Now when we enter this screen, you'll see there's several nodes up at the top. These are the variables grouped by function. So we have our fluxes, our meteorological data, our radiation data, soil data, turbulence, water, and so forth. And I can click on one of these particular nodes, and all of those variables then are listed for me. And when I do a QC screening, I can go through all these different variables and set all the different criteria that I'd like to do for my analysis. Now what you'll notice on these charts is this particular analysis that I've created here was for the month of July 2013. So you'll see that time series of data here. Okay, on the right hand side we have a chart of the ensemble average of that data plotted on the left. So for example, I can come onto this chart and I can see that from 8 o'clock every day during my date range on the left, I have a chart showing me what the minimum value is, the maximum value, and some other statistics. Now that graph on the right is also responsive to changes we do on the left. Now some of the charts might have an extreme outlier. For example, this case here is a CO2 storage term. We see a point here that's causing the y-axis to really expand to values that make it impossible to do QA/QC on this data without doing a lot of zooming. So we included this button here, which uses some statistics and throws out these outliers so it can then zoom into a view of the data that allows us to do the QA/QC and work with that data. Now let's do some QA/QC by looking at the sensible heat variable here, H. Now again, this top line here is a maximum threshold. I can drag this value down, and you will see that these points become excluded and turn colors. And then I can do the same thing for a minimum value by dragging this red bar up. And what you'll notice is these points below the line then are marked as excluded. Again, on the right-hand chart, you can see that these numbers change responsively based on where I'm moving these max and min thresholds. Now, for example, let's say we want to do a date range exclusion. For example, one of the instruments might have been malfunctioning, or we were performing a calibration. I click on this exclusion box here, come over to the chart, and then simply drag my mouse across and highlight a particular period in which I want to exclude data from. Now if I want to fine-tune this data set exclusion to a specific date and time, I click on my edit pencil, and in here I can enter the exact date and the exact time that I want to do my exclusion on. Now, a lot of this functionality of the quality screening has built off a code that was developed over the years by the OzFlux community. And so over here on the right-hand side, we provide information for each of our tools with an acknowledgement icon. If I'm to click here, a panel will slide out, and this will tell me about the code, who had written it, if there are any publications behind it. For example, this particular publication was written by Peter Isaac and his colleagues. I can click here to also show all the other authors that were involved, and I can link to their ResearchGauge profile or their independent web page. So this allows you to feel comfortable knowing that a lot of the codes and algorithms inside the software were provided by the community, and we're citing that work here in the software. Another icon over on the right-hand side that could be useful is the metadata icon. If I want to have a quick look to maybe find out what my canopy height was or what the sonic anemometer height was, I can open that and have a quick look there. The third icon over here is the help icon. And so this gives me some tips for how to use the tools on the particular software screen that I'm in at the time. Okay, so we've come back to our screen, and now the tools I've showed so far are easy for doing the max and the min and also dates, but there's definitely going to be times in between where the quality of the data might not be good because the conditions weren't right for doing eddy covariance measurements. And there is some flagging for that using the Foken flags that are developed by Thomas Foken and are used in EddyPro. So those flags are carried over when you've imported the data. If I click on this quality flag icon here, I'm provided with a slider bar. Now the slider bar goes from 0 up to 2 for the quality flags that are used for determining good quality data with the fluxes. And if I want, I can simply slide this bar over and decide I want to only include data that's flagged with a 0 or a 1. And when I do that, you'll notice that you'll start to see some of these points getting excluded here between the min and the max thresholds. I can even slide it all the way over and say I only want to include the best quality data in my analysis, and you can see a few more yellow points start to emerge. Now I can also come to this legend, and I'm presented with a pop-up that shows me exactly how many points were considered good quality, how many are bad quality, how many points are missing, and then each of those tools that I've done, for example, the max and min, the exclusions, and the Foken dependency shows me how much data I'm throwing out using each of those tools. And that might make it easy for me to decide if I want to accept those or move on. So from here, I would go through and do this QC screening on all the different variables. And when I'm done, I go over here and would click this Done QC button, which would actually apply all the settings I've done through this QC screening tool to the data, which could then be exported. I'm not going to do that yet. Stay tuned for the next tutorial in which we look at the dependency view. This particular session will again focus on the QC screening tool. In particular, we're going to look at the dependency view. So again, we'll go into the toolbox at the top menu and click on quality screening. In the last session, which you haven't seen before, you can go watch that video. We've already done some QC screening on the sensible heat variable. What I wanted to show in this particular session is up here in the upper right called the dependency view. We'll go ahead and start this dependency view. Now several of the variables that we're collecting are dependent on several other independent variables. And you might want to screen your dependent variables based on the independent variables that could be faulty, out of range, inaccurate, things like that. So what we do is we select the variable that is our dependent variable. In this case, we can go ahead and select the sensible heat, which is the one we've been working with, and you can see all that current state is brought over. And then down below, we have a couple default independent variables. We have W variance and T sonic variance down here. Now, what we can do, for example, is take this maximum for the W variance like we explained in the previous session, drag this down and exclude some points. And what you'll notice is that these same points now are cleaned off up in the dependent variable automatically. Down here, you can see we have T sonic variance. Again, we have this this outlier that's making the graph a little bit too large for us to work with. We use the smart Y range and do some quartile statistics to get it down within a workable range. Now here, for an example, let's just assume we have some bad data in this region here, and it might be affecting our sensible heat. If I feel uncomfortable with this data set for some reason, I was doing a calibration or there was a faulty sensor, I highlight that, and as you notice up top, now that is automatically defaulted for me. And again, these ensemble averages are all updating at the same time. Now for an example, let's say I want to bring in my own new dependent variable. For sensible heat, for example, let's say we want to also have the independent variable air temperature associated. So I come up here to click on Add Dependency. From the list, I can find air temperature. And what you'll notice now down below here is I have a third dependency that I can do stuff with. One of the nice features here is if I want to zoom in on my X scale and have all the graphs zoom in the same way, I use this lock zoom function. And then let's assume I want to look at a particular period of the data. As I do that and drag my slider across, you can see all the three graphs update to that same zoom. And I can come in here and decide to do some fine tuning of my min and maximum. I can again draw some exclusions and clean up the data as I want, and you can see that gets affected there. So that is how the dependency view works. And now that I'm ready to move on, if I've done this to all the variables, I go ahead and click on Done QC, and all of the settings that I've been doing throughout this entire QC toolbox will take effect to the data. I'll go ahead and I can name this particular operation something that I've been doing. For example, cleaning sensible heat. I hit continue. I can name that whatever I want, and it will tag my data and let you know that when I go back and look at particular nodes on what I've done in a particular tool, that tag is some good information to let me know exactly what happened. And so now we come back to our overall coverage chart. A couple things to notice. One is I now have a new node up here in my historical workflow. It let me know that I've done some work from raw data, and I'm now at the stage of the QC. You can see it's labeled cleaning sensible heat. And you'll also notice that now a lot of my fluxes are trimmed down. I have less coverage and less variables now in that data set. And I can specifically go look at sensible heat H here, and you can see all the different areas we cleaned out. So it gives you a quick indication of the work we've done so far. And that will wrap up this particular session.